In this video, we're going to take at how we can reduce fractions. To reduce a fraction, what we will do is divide out any common factors. This means it may be helpful to know what those factors are we can divide out by finding the prime factorization. So let's see if we can find some prime factorizations of a fraction and then divide out the common factors. Let's consider the fraction 60 over 80. First, we need the prime factorization of 60 and 80, which we can find by dividing out prime numbers. 2 goes into 60 30 times. 2 goes into 30 15 times. 3 goes into 15 5 times. And 5 goes into 5 once. So in the numerator, 60 is 2 squared times 3 times 5. Actually, we're not going to write this as 2 squared. We're going to write it out as all the factors. 2 times 2 times 3 times 5. Similarly, we need to know what the prime factorization of 84 is. 84, it's even, divisible by 2, 42 times. Still even, divisible by 2, 21 times. We know that's divisible by 3 7 times, which is divisible by 7 once. And so we get this for our prime factorization, 2 times 2 times 3 times 7. And what we see is there are several factors that are in common in both the numerator and denominator. Notice we've got 2's from the numerator and denominator. Those can divide out. We got another pair of 2's that divide out of the numerator and denominator. Again, there's a pair of 3's that divide out, one from the numerator and one from the denominator. It's very important we're always grabbing one from the top, one from the bottom, one from the numerator, one from the denominator. No more common factors. We'll multiply what's left. Well, all that's left is this 5 and 7, so this fraction has reduced to 5/7. It is completely reduced when there are no more common factors that can be divided out. Some people would rather take a look at a problem like this, though, and instead of going through the work of finding the prime factorization like we did here, you might be able to identify what those common factors are by just looking at the 60 over 84. We might have been able to see that they're both divisible by 2 because they both end in an even number. So let's take a look at another example. 50 over 30, and see if we can use that shortcut. Instead of finding the prime factorization of 54 and the prime factorization of 30, what we're going to do instead is look at these two numbers and say, can I identify what a common factor that they're both divisible by is? Well, they're both even. So they're both divisible by 2. So let's divide a 2 out of both of them. 54 divided by 2, when we divide out 2, will leave us 27. Over 30, when we divide out a 2, gives us 15. And then we can look at these numbers and decide, is there something I can divide both of them by? Is there a factor I can divide out of both the numerator and denominator? We can recognize 27 and 15 are both divisible by 3. And so we're going to divide both of them by 3. 27 divided by 3 is 9. 15 divided by 3 is 5. And now we get this fraction 9/5, which you'll notice has no common factors. There is nothing that we can divide both 9 and 5 by, so 9/5 becomes our reduced solution. So really, there's two ways we can go about reducing a fraction. One, we can identify the prime factorizations and divide out all those common factors in the numerator and denominator. Or, like we did on the second example, if you can see what those common factors are from the beginning, we can just divide them straight out and see what we reduce down to our simplified reduced fraction.